In this lesson, we will be graphing and writing with inequalities. When you hear the word inequalities, I wonder what you think of. An inequality is a statement that two quantities are not equal. In all other equations we've been using an equal sign, which means that there is one solution. If you say x is equal to 5, then 5 is the only solution. But in inequalities, there will be more than one number that is the correct solution. And so we use what we call inequality signs. So you will see here there are 5 inequality signs. Do you recognize them? If you look at this one, do you know what this sign says? It says less than. The next sign says greater than. Now how do you know which is which? Well, in English we read from left to right. So if you were to read from left to right on this, notice that on the left side, this is where it's pointy, this is where it's close together, so that's less. Here when you read left to right, this is the wide part. Because this is wide, it's greater than. So less than and greater than. If you include a line like this underneath it, it means it's greater than or equal to. The next one is less than or equal to. And the last sign is not equal to. So you need to recognize these 5 signs and what they mean as we go throughout this lesson. So if I were to ask you to graph x equals 10, we are using an equal sign. So there's only one solution. So if I were to ask you to graph that on a number line, you would simply do it with a single point filled in on 10 on a number line. And that reads x is equal to 10. So if you're taking your notes, this is what you write. X is equal to 10. And then you show how you graph it there on the number line. But what if we have this one? This one reads, how do you read this up here? It reads x is not equal to 10. So if x is not equal to 10, then what is x equal to? That means that x would be equal to every other number except 10. So to show that on a number line, what we do is we put what I call a circle dot on 10. It's not filled in, and then an arrow going to the left and an arrow going to the right, showing that it's every number greater than, every number less than, but not 10. If it had been 10, we would have filled that dot in. Because it's an open dot, then it's not equal to that. How do you read this one? This one reads x is less than 10. So how would we graph that on a number line? Since it's not equal to 10, but it's all numbers less than that, we do something called an open dot or a circle dot. I use both terms synonymously. So open dot. That means it's not equal to 10, and then we have an arrow. Now here's something you can do. If the variable is on the left side of the equation. Now we could flip this thing. If we were to flip it, it would look like this. Notice that when I move the variable from the left side to the right side, I had to flip the sign because the narrow part of the sign is closest to x. The narrow part of the sign is closest to x. But if you have it written where the variable is on the left side, this sign shows you the direction of the arrow. So here's your arrow. So this variable is on the left. It shows you it's less than, and so it's going to go to the left with an open dot because it's not equal to. Okay, the next one says x is greater than 10, but not equal to. Since it's not equal to, again, we're going to graph it with an open circle, but this time the arrow is going to go to the right. Again, the variable is on the left side, so this sign points in the direction that the arrow goes. This one has the line beneath it. So this one says x is less than or equal to 10. So instead of using an open dot, here's what it says. X is less than or equal to 10. If you're taking your notes, you would write that down. This time we're going to use a colored in, a filled in dot, because it does include 10. There's a difference between an open circle and a filled-in circle. This one means it's equal to 10 as well, and all numbers less than. Notice that the skinny part of it is towards this. This is less than. And the variable's on the left, so the arrow goes to the left. This one, what does it say? It says x is greater than or equal to. Greater than or equal to. Again, it's equal to, so we're going to use a filled-in dot on 10, but this time the arrow is going to go to the right. This one looks a little different. So here's our variable in the middle. So the way we would read this is x, so we're going to talk about x first, is between, see how x is between these two numbers? You could say x is between negative 10 and 10, or you could read it, start reading right here and read this direction and say x is greater than, see how the wide part is next to the x? You have to read backwards this way. X is greater than negative 10, and now you read this way. X is less than 10. You can read it either way. This time, since it's in between, because the x is nestled in between two numbers, we'll see that it has to be between these two. They are open circles because there's not a line underneath them, and it's everything between those two numbers. So this time, instead of an arrow, you have a definite beginning and a definite ending. Okay, this is the same thing except of the equal sign. You could either read it that x is between and includes negative 10 and 10, or you could start here and read this way and say x is greater than or equal to negative 10, and start here and read this way, x is less than or equal to 10. But because the variable is nestled in between those two numbers, we know it's in between or equal to, so we have the filled-in dots with a line that connects because it's in between those two numbers. If a DVD cost more than $15, how would we graph that and how would we write it? Well, first we need a variable that represents the DVD. You can choose any variable that you would like. Usually we choose variables that represent that DVD. If it's more than is the same thing as greater than. I'm not sure why I used N. D would probably be a better letter, but the cost of the DVD is greater than $15, but not equal to. So we have a open dot on 15 with an arrow going to the right, because it could be $16, it could be $30, it could be $40. It's more than 15. And this is just a reminder again about what I said. To know what direction to write the graph, write it with the variable to the left. Then the arrow goes in the same direction. So here the variable is on the left side of the equation. So we know this symbol shows you the direction of the arrow. If I were to flip it and write the variable on the right side, since the greater part of the symbol is toward the variable, I have to flip the sign, and it reads the same way, except this time you have to read this way. N is greater than 15. So it reads better when you have the variable on the left side. A dog weighs less than 50 pounds, so less than. Any number that's less than 50, it could be, now actually I looked at this and this is not exactly how I would graph this. You have to make a little sense out of this one. If a dog weighs less than 50 pounds, you know it's 49 pounds or below, but you can't have a dog weighing less than 0 pounds. It cannot be negative weight. So technically, this one should be like this. This means the weight of the dog would be between 0, filled in, can a dog weigh 0? I don't think a dog can weigh 0. So somewhere between 0 and 50 pounds. So you have to think about these things and think, hey, could this arrow go indefinitely in this direction? Or is there a stopping point? And there's definitely a stopping point here because animals cannot have negative weight. Height requirement is greater than or equal to 40. So N is greater than or equal to 40. Because it's equal to, this time we use the filled-in dot. It could be 40, you could be 41, you could be 42 and a half, you could be 45 3/4. Anything greater than that. The speed limit is less than or equal to 35 miles an hour. So here's how we write it. Speed limit is less than or equal to 35. Again, this is one you can't have negative speed, so it would really have to start at 0. And then at 35, it's equal to, if we fill in the dot, it would have to be between those two numbers. You really couldn't use an arrow, because if you use an arrow, you means it could go indefinitely into the negatives. And unless you're time traveling or something, I don't think you could have negative speed. So that arrow is really not right. It really should cut off right there. Determine the truth of an inequality. So if we have this equation up here and you were to graph it, they're asking, would -1 be one of the possible solutions? Well, with this, all we have to do is plug in the number and see if it's true. We think if t is equal to -1, it means we plug in -1 to t. And we would have 2 times -1 plus 8 is greater than 7. Let's see if this is a true statement. We do our multiplication first, and 2 times -1 is -2, plus 8 is greater than 7. I just copied the rest. When we add with different signs, we subtract and keep the sign of the one with the greatest value, so that would be 6 is greater than 7. Is that a true statement? Is the number 6 greater than the number 7? That is not true. So that means if I were to graph this, -1 would not be part of the line or the solution, because that is not a true statement. Okay, again, we're going to test to see if we were to graph this, would 40 be part of the arrow, be part of the solution? Again, we're going to plug it in. So in place of p, we're going to put 40. We're going to copy the rest of the equation. Now we're going to solve it. We have a positive and a negative. Different signs subtract. That's a -2. Is -2 less than or equal to -2? It's not less than, but it is equal to, so that is a true statement. So 40 would be one of the solutions. Okay, now just to graph. X is greater than 6. We have the variable on the left. It reads x is greater than 6. We do an open dot because it's not equal to, and it's greater than, so it's going to go to the right. X is less than or equal to -1. Because it's equal to, we're going to use a filled in dot on -1, and it goes to the left because it's less than. Same direction as this arrow right here. As long as the variable's on the left, that works. X is greater than 0. Here again, we have the variable on the left. This shows us the direction. It's not equal to, so we use an open circle, and we go to the right. Now let's see if we can write the inequalities. So you start with the variable x. Now, the arrow is going to the left, so this right here shows us our sign. It's a less than sign. And it's not equal to because it's not colored in. And then we just write this number. X is less than -1. Okay, this time we have our variable, whatever variable we choose. Here's our arrow, so this shows you what our sign is. It's greater than. And since it's filled in, it's also equal to. And then we look at the number where it is. So x is greater than or equal to 2. Okay, let's use in. Let's look at the sign. Here's our arrow. Look, this shows you our sign right here. It's greater than. It's not equal to because it's not filled in. And the number is -2. N is greater than -2. Oh, 2.5? Oh, I don't think that's 2.5. That's not 2.5. That's right on 2. And hopefully that helps you with inequalities.